A gemstone or gem, also called a precious or semi-precious stone or jewel, is a piece of mineral which in cut and polished form is used to make jewelry or other ornaments. A gemstone or gem, also called a precious or semi-precious stone or jewel, is a piece of mineral which in cut and polished form is used to make jewelry or other adornments. However, certain rocks such as lapis lazuli and organic materials such as amber or jet are not minerals but are still used for jewelry and are therefore often considered being gemstones as well. In mineralogy, there are several thousand listed minerals, but only about 60 of these have the necessary qualities of beauty, rarity, and durability to make them suitable for use as gem materials. Within this select group of some 60 gem materials, there are several metallic minerals. These include gold, silver, platinum, and the platinum group metals, rhodium and iridium. With a few exceptions such as lapis lazuli, which contains a mixture of lazurite, sodalite, calcite, and pyrite and can therefore be classified as a rock. The majority of gemstones are composed of just one mineral. Minerals are split up initially into a series of groups, each of which contains those minerals which have similar features or characteristics. In gemology, with its more limited number of gem minerals, there are only a few which have enough in common to qualify under this heading. These are the feldspar, garnet, and tourmaline groups. Gem minerals are further subdivided into species which have their own individual chemical composition and characteristics, and varieties of species which differ from each other only in color or general appearance. In this chapter, we will discuss the following sections in relation to gemstones: origin of gemstones, classification of gems, gemstone qualities, gem testing and gem measurement units. The origin of a gem is its place of genesis in the Earth's crust or mantle. Except for organic substances such as amber and jet, sedimentary rocks contain no primary gem material. However, if the pre-existing weathered rocks contain heavier minerals, that is, gem minerals, these may have been washed out and swept away to form secondary or alluvial deposits. Most of our important gem minerals such as feldspar and quartz, tourmaline, beryl, topaz, and zircon originated in intrusive or plutonic igneous rocks whose slower rate of cooling in the middle and lower parts of the crust made it possible for quite large crystals to form from the original molten residues. As the temperature of the magma began to drop, minerals separated out in a process known as fractional crystallization. The feldspar were the first to solidify, and having plenty of space, they produced large, well-shaped crystals. As the magma continued to cool, other minerals crystallized out. Of these, quartz was the first of the last to solidify, and as it had been much lesser room than the others to grow, was not always able to produce such large and well-defined crystals. Many of the intrusive gem-bearing rocks formed as coarse-grained granites called pegmatites. Geodes also originated in igneous rocks in which quartz and other minerals have been precipitated as crystals in almost spherical cavities formed by chemical-rich molten or aqueous residues trapped in the magma. The chemical reactions generated in metamorphic rocks when molten magma was forced into cooler rocks created the gemstone varieties of emerald, alexandrite, ruby, and sapphire. Other gem minerals were formed as a result of the large-scale shearing and crushing of rocks. Examples of these are garnet and elusite, serpentine, nephrite, and jadeite. Diamonds differ from the rest of the gem minerals in that they were formed somewhere in the region between the lower part of the Earth's crust and the beginning of the mantle. The manner in which gemstones were created in nature can be related to the sedimentary, igneous, or metamorphic processes of rock formation as well as the chemical content of molten and aqueous residues. The occurrence of a gem is the geological environment in which it is found or mined. For example, gem gravels, gem-bearing veins, or a diamond pipe. Many gemstones are found at the site where they were originally formed, and this type of deposit is of particular interest to the mineralogist as it provides evidence of the method of gemstone formation. Alluvial gem deposits, on the other hand, are the result of gemstones which have been carried from their place of formation either by weathering agents such as wind or rain or by rivers. Evidence of the distance traveled by gems found in alluvial deposits can be seen in their abraded surfaces. For example, water-worn topaz pebbles and the rounded profiles of diamond crystals from the Namibian coastline. Sometimes gems that were released from rocks by weathering have been deposited with little or no transportation or concentration from the site of the parent rocks. These residual deposits are described as alluvial, Some areas of the earth seem to have been more blessed than others by geological conditions favorable to the formation of gemstones deposits. Sri Lanka is the host to a wide range of gem varieties including ruby, sapphire, the more common varieties of garnet, chrysoberyl, alexandrite, quartz, moonstones, spinel, topaz, zircon, tourmaline, and elusite and synhalite. The Malagasy Republic has aquamarine and the pink variety of beryl, but not emerald. Many of the varieties of quartz and garnet, plus topaz, tourmaline, orthoclase, feldspar, and kunzite variety of spodumene, Myanmar and Thailand have rich sapphire and ruby deposits. Australia has the diamond, sapphire, and opal fields, which are major sources of these gems. In South America, there are the famous emerald deposits of Colombia and Brazil, the latter also being a prolific source of amethyst, aquamarine, and topaz. The North American continent, among many varieties, contains important sources of tourmaline, while Russia, the first alexandrite deposits were discovered here in Siberia. We find malachite, tourmaline, the demantoid variety of garnet, including all the varieties of quartz and the heliodor, aquamarine, and emerald varieties of beryl. Other commercially important deposits of emerald are mined in India, Pakistan, Zimbabwe, and the Republic of South Africa, which is also well known for its tiger's eye variety of quartz and is one of the world's major sources of diamond. Equally important are the diamond mines in the Siberian plateau of the Confederation of Independent States, CIS, formerly the USSR, in the People's Republic of China, and in Australia, although historically India was the first source of diamonds, followed by Brazil. Both of these countries are now only minor sources of the gem. In the Argyle mine in Western Australia, the transport rock magma has a different composition to the kimberlite, in which diamonds are found in southern Africa and is called lamproite. Another relatively new source of diamonds is being mined in the Canadian Arctic territories at Lac de Grasse. The recovery of gems from the earth's crust varies from simple manually intensive methods to highly mechanized operations. The alluvial deposits are often discovered in the area of floodplains or along the courses of ancient dried up river beds. Sometimes the gem-bearing gravels are found nearer the surface in the beds of the existing rivers, and cofferdams and section dredging techniques are employed to recover the stones. Where there is a bend in a river, the water flow on the inside of the bend will slow. At this point, denser minerals such as gem materials and precious metals will sink and form a placer deposit. If the river meanders, forming an oxbow, the U-shaped collar of an ox yoke, a channel may be cut from bank to divert the river. The bypass section of the river is then dammed and pumped dry to enable the recovery of gem gravels. Where the gem deposit is nearer the surface and is spread over a large area, as in the case of some topaz deposits in Brazil, a more mechanized mining operation is employed. Wide stretches of topsoil are removed by a dragline excavator, which is then used to gather in the underlying gem-bearing soil. The silt is washed out by the use of sieves and high-pressure water jets, and the topaz crystals recovered by hand-picking. The methods employed in diamond mining range from the simple alluvial riverbed operations, where the stones are separated from the gravels by means of a panning operation, similar to that used when panning for gold, to highly mechanized shaft mining. There is not one say to classify gems, rather there are several ways, each of which has its own purpose and its own exceptions that warrant close attention. Precious and semi-precious. A couple of centuries ago, the terms precious and semi-precious gems came into common use. There are so many exceptions to this classification that it no longer has any value. For example, diamonds have always been considered precious gems, yet there are diamonds that sell for $100 a carat. You can see them with sufficient magnification as essence stones or inexpensive jewelry. On the other hand, there are garnets that sell in excess of $1,000 a carat. Garnets have traditionally been considered semi-precious gems, but some of them are worth more than 10 times a low-quality diamond. Natural and man-made. There are a couple of terms commonly used for gem material, that is, created in a laboratory. Synthetic refers to materials that duplicate their natural counterparts. It is quite common to see synthetic material for emeralds, sapphires, and spinel. Organic and inorganic. Another approach is to separate gems into organic and inorganic. Inorganic gems are those whose creation is associated with living organisms. Amber, for example, begins life as tree sap, and pearls are created inside oysters. Hence, they are classified as organic materials. The term inorganic covers everything else. So everything in the mineral world falls into the inorganic classification. Crystalline and amorphous. Differentiating between crystalline and amorphous materials is another way of gemstones are classified. The term crystalline refers to minerals that are comprised of a repeating pattern of crystals, while the term amorphous is used to describe minerals that have no set form or shape. While many gems are crystalline in structure, not all gems are crystalline. Amber and opal are good examples of amorphous materials. Aggregates. The term aggregate applies to collection of small gems that form together. Aggregates form when the requirements needed for crystal formation, such as the presence of certain chemicals, heat, pressure, time and space, are not present for the necessary amount of time. For example, if the material cools off too quickly or there is not enough space for the crystals to grow, an aggregate forms instead of one full crystal. Rocks. Rocks are comprised of a mixture of minerals, whereas crystals and amorphous materials have a single main ingredient. While not a gem material, granite is one of the most common and best known rocks. If you look at it carefully, you will see black, white and gray bits all around together in a single material. Though you do not see too many rocks in gemology, there are a few, including lapis lazuli, the most well-known rock in the gem world. Minerals. The vast majority of gems and mineral species are defined by a combination of their chemical makeup and their molecular structure. Chemical makeup refers to the atoms contained within the mineral. Diamond, for example, has the simplest chemical makeup, with carbon, C, being the only element present. Corundum is composed of just two elements, aluminium and oxygen. The appearance of a gem is a combination of many separate factors, each of which is related to and affected by the others. It is precisely the complexity of these intertwined relationships that has bedeviled all attempts to quantify quality. The criteria to objectively evaluate the beauty of gemstones have been developed through the years and can be summed up by the Anglo-Saxon 4Cs formula: color, cut, clarity and carat. The quality and beauty of a gemstone are related to the balance of these four parameters. Color. The first C, for a colored stone, any gem other than diamond, color is the most important factor in determining quality. To the color scientist, given an opaque, matte finished object, there are three dimensions to color: hue position, saturation, that is intensity, tone, that is lightness or darkness. For colored gemstones, there is also a fourth factor: color coverage. Clarity. The second C, clarity, is judged by reference to inclusions. Magnification can be used to locate inclusions, but with the exception of inclusions which might impact durability, only those visible to the naked eye should influence the final grade. In this way, colored gems are very different from diamond. There are two key factors in judging clarity. These are visibility of inclusions, size. Smaller inclusions are less distracting and thus better. Number, generally the fewer the inclusions, the better. Contrast. Inclusions of low contrast, that is compared with the gems Ri and color, are less visible and thus better. Location. Inclusions in inconspicuous locations, that is near the girdle, rather than directly under the table facet affect value less. Similarly, a feather perpendicular to the table is less likely to be seen. Impact on durability. Impact on durability. It depends on two factors, type and location. Type. Unhealed cracks may not only be unsightly but also lowers a gem's resistance to damage. They are thus less desirable than a well-healed fracture. As already mentioned, tiny quantities of exsolved silk may actually improve a gem's appearance and thus value. Location. A crack near the culate or corner would obviously increase the chances of breakage more than one well into the gem. Similarly, an open fracture on the crown is more likely to chip than one on the pavilion. Inclusions in certain positions may also reflect making a single inclusion visible throughout a gem. Cut. The third C. The function of the cut is to display the gem's inherent beauty to the greatest extent possible. Since this involves aesthetic preferences upon which there is little agreement, such as shape and faceting styles, this is the most subjective of all aspects of quality analysis. Evaluation of cut involves 5 major factors. They are 1. Shape, 2. Cutting style, 3. Proportions, 4. Symmetry, 5. Finish. Carat weight, the fourth C. Weight in gems is calculated in metric carats, where 5 carats equal to 1 gram. Generally, as a gem's weight increases, so does the per carat price. Such a relationship has long been known and was first quantified by Villefane in the year 1572 for diamonds. Today, it is most commonly referred to as the Indian law or Tavernier's law and works as follows. WT square into C equals to price per stone. Weight of gem equals to 5 carat weight. Cost of 1 carat gem of equal quality equals to $1,000 C. 5 into 5 into 1,000 equals to $25,000 total stone price. Gem identification is basically a process of elimination. Gemstones of similar color undergo non-destructive optical testing until there is only one possible identity. Any single test is indicative only. For example, the specific gravity of ruby is 4, glass is 3.15 to 4.2, and cubic zirconia is 5.6 to 5.9. So, one can easily tell the difference between cubic zirconia and the other two. However, there is overlap between ruby and glass. As with all natural materials, no two gems are identical. The geological environment they are created in influences the overall process, so that although the basics can be identified, the presence of chemical impurities and substitutions along with structural imperfections create individuals. Identification by refractive index. Every material has a critical angle at which point light is reflected back internally. This can be measured and thus used to determine the gem's identity. Typically, this is measured using a refractometer, although it is possible to measure it using a microscope. Identification by specific gravity. Specific gravity, also known as relative density, varies depending upon the chemical composition and crystal structure type. Heavy liquids with a known specific gravity are used to test loose gemstones. Specific gravity is measured by comparing the weight of the gem in air with the weight of the gem suspended in water. Identification by spectroscopy. This method uses a similar principle to how a prism works to separate white light into its component colors. A gemological spectroscope is employed to analyze the selective absorption of light in the gem material. Essentially, when light passes from one medium to another, it bends. Blue light bends more than red light. How much the light bends will vary depending on the gem material. Coloring agents or chromophores show bands in the spectroscope and indicate which element is responsible for the gem's color. Some of the most often used gemological testing equipments are gemological binocular microscope. These microscopes are great for research, retail, selling and identification of difficult gemstones such as some synthetics. 10x triplet jeweler's loupe. With this, one can separate synthetic moissanite or cubic zirconia from natural diamond, clarity grade a diamond, cut grade a diamond. Maglite with dark field. Meant for those of you who need dark field illumination to do clarity grading without using a microscope. Refractometer. The refractometer gives the refractive index including the optic character and sign of the gemstones. Gemmeter, that is infrared reflectance meter. The gemmeter is a digital tool and the best for testing refractive index of a stone. It will read far beyond the 1.81 reading of the normal glass versions of refractometer and also test for birefringence, hence eliminating the need for a polariscope. Polariscope identifies single and double refractive gemstones and in many cases allows to view the optic interference figure and give the optic character of the gemstone. Diachroscope, critical in identifying many synthetic and imitation gemstones. The diachroscope allows us to see the pleochroism in a gemstone. In other words, it allows us to see the multiple colors that many gemstones produce. Chelsea filter. Chelsea filters are simply diachromatic filters used to separate some natural emeralds from imitations and other green gems. A spectroscope. The spectroscope allows you to see the absorption lines due to elements in a gemstone that allows for identification. Carat is the international metric unit used for measurement of gems. Abbreviated CT, it is equivalent to 0.2 grams. So, there are 5 carats per gram. The metric system is the basic international standard used for gem commerce. The ounce, a familiar English unit of weight, equals approximately 142 carat. The ratti, as a measure of weight, was used during era before rule of Emperor Akbar and still used in India in domestic markets. Ratti is an egg-shaped scarlet red seed with a black spot on one end of the plant Abrus precatorius, which is known as gunja in Sanskrit and chirmi in Hindi. Divergent data emerges from several parts of India about the ratti. 1 ratti equals to 0.91 carats. 200 milligrams equals to 1 carat or equals to 100 cents. 182 milligrams equals to 1 standard ratti, astrological stones ratti. 121 milligrams equals to 1 sonari or jeweler's ratti equals to kachi ratti. 1 gram equals to 5 carats, that is equal to 1000 milligrams. Going by the above, there should be a single standard value for Ratti regardless of where you go. It has to be universal, but the fact of the matter is, it isn't. Gem minerals are split up initially into a series of groups, each of which contains those minerals which have similar features or characteristics. Gem minerals are further subdivided into species which have their own individual chemical composition and characteristics, and varieties of species which differ from each other only in color or general appearance. The origin of a gem is its place of genesis in the Earth's crust or mantle. As the temperature of the magma began to drop, minerals separated out in a process known as fractional crystallization. The recovery of gems from the Earth's crust varies from simple, manually intensive methods to highly mechanized operations. There is not one way to classify gems. Rather, there are several ways, each of which has its own purpose and its own exceptions. The quality and beauty of a gemstone are related to the balance of color, cut, clarity, and carat. Thank you very much.